Hello everyone. In today's class, I am going to discuss some materials from chapter 2. So here is the chapter 2 materials that I am going to discuss today. So I am going to discuss only maybe first 2 or 3 sections of the chapter 2. Chapter 2 of this book discusses about descriptive statistics, which consist of central tendency. Central tendency mainly indicate like mean, median, and mode of a data sets, and also there are dispersion, which stands for standard deviation, variance, and covariance. These are the materials for the uh, central tendency and dispersion thing. In addition to that, there are also graphical representations. For example, for the qualitative data and quantitative data, how can we represent those data in graphical format? So there is a bar chart and pie chart. Bar chart and pie chart are constructed for qualitative data, more specifically categorical data. For example, eye color of the people, for example, race of the students, for example, smoking habit of the people. So these are the categorical variable. For this categorical variable, the graphical presentations could be done by using bar chart and pie chart. And there are also chart which are known as the group bar chart and stack bar chart. So group bar chart means, suppose I want to compare the education level by race. For example, African American and Caucasians. For the African American, I want to create one bar. In that bar, there is a segment of educations. So what portion have a highest education level, college education level, high school education level, and primary education level, something like that. Those could be done either by stack bar chart or group bar chart. So let me conclude the introductions for the business analytics chapter 2 by explaining what are the materials that will be covered in chapter 2. In the chapter 2, mainly the materials that will be covered are central tendency and dispersion, and then graphical representations, and some kind of Excel or R program will be introduced in order to demonstrate, in order to show how like the central tendency measure like mean, median, mode are computed and graphs are constructed. So let me move to the second slide. Second slide is giving you the topics that we are going to discuss on chapter 2. So overview of using data, definitions and goals. There are many definitions that we are going to discuss as well. Okay. So types of data. What are the types of data? There is a many different, remember, types of variable and types of data are different. Variable and data are different. Variable is a part of the data. Variable is within the data. Data is a big format. Data is in a rectangular format with column representing variable and rows representing the observations or subject or measurement of a subject. Remember, data is a rectangular representations of some numbers. Either it will be quantitative or it is qualitative, where column represents the variables. Another name of variable is feature. Like statistics people, they call variable, but the computer science people, machine learning people, they call it as a feature. And row is known as the observations or subject. Okay. So this is called the data. and variable and data are two different things. Okay, now exploring data in Excel. We will open some Excel data and show you how they look like. And then these Excel data we will run in R or Python, and the computations that we are going to do by using Excel will also be done using Python and R. These two courses, Business Analytics 1 201 and Business Analytics 2 260, will have lot of materials that will be covered by paper and pencil approach as well as by software approach, either or and both, like either Excel, R, or both Excel, R, and Python, all of these things. Okay, now the creating distributions from the data. What does this mean, creating distributions from the data? I have a data, that data has a variable income, that data has a variable educations. From education and income level, I can create a distribution. So distribution means education level 1 means no educations, and income level is the lowest. Lowest means income level, 1 means lowest. So I want education level and how many of them has a income level lowest. So this is the way you can create a distribution from the data. Distributions means from the data we are creating how many people belongs to each group. Now, measure of location. So if you have a data and if you arrange the data in the ascending order, middlemost observation is known as the median. And then if you add all the observations, all the values of a variable and divide it by the total number of observations, then it is called as a mean. And mode means what? Mode means is the that observation which has the highest number of frequency. So mean, median, mode. And measure of variability. Measure of variability means suppose there is a grade of business analytic students from University of Southern Mississippi, and also there is a grade of the business analytics course from the Mississippi State University. Okay, so now suppose 100 students from University of Southern Mississippi, they have a average, and each data point on an average from its mean how much variations exist, that is known as the variance. Okay, and then square root of variance is called the standard deviation. So if that formula is used, to compute variability between the students of University of Southern Mississippi and Mississippi State University, and if Southern Mississippi University student have a higher variability compared to the Mississippi State University, then we say that the students in the Southern Mississippi is Business Analytics 1 course has a higher variability compared to the Mississippi State University. How that thing could be computed? That thing could be computed by a measure known as the standard deviation, which I will discuss. Now, analyzing distributions. How when the data are put in some kind of graphical format, and then that graphical format is known as the histogram, and the top middle point of each bar are connected by a smooth line, then that is known as the frequency curve. If frequency curve is symmetric, then that distribution is known as the symmetric distribution. If that frequency curve has a long right tail, then that distribution is called the skewed to the right or positively skewed. And if that curve has a long left tail, then that distribution is called the skewed to the left. Measure of associations between two variables is done by the covariance. When the supply is increasing, price is decreasing. So that thing could be done by the covariance. When price is increasing, demand is decreasing. That thing, price and demand, that thing, two variables are correlated. That thing could be measured by the covariance. And finally, summary statistics. Even though you are saying like section 2.1 to 2.8, today we are going to cover only 2 sections or 3 sections, not all the sections. But these are the topics that we are going to discuss in chapter 2. So chapter 2, we will discuss some definitions and goals. And so, for example, some definitions, right? So if someone asks me, provide some definitions, I want to provide some definitions such as statistics, and then population, statistics, population, sample, population, sample. Okay, let me discuss these 3 definition first, and then I will discuss later some other things. Okay, so before started discussing, let me discuss learning objective of this chapter. What we are going to learn after completing chapter 2. There are 3 phrases of detailed descriptions of learning objective after completing chapter 2. First one, identify and describe different data types. See, data and variable are 2 different things. Data type and variable type. Variable are usually 3 types or 4 types if you can make. First of all, variable. What is variable? Variable means the characteristics or attribute that varies from circumstances to circumstances, places to places, is called the variable. The characteristics or phenomena that varies person to persons, places to places, or circumstances to circumstances is called the variable. Remember, the characteristics or phenomena that vary from person to person, places to places, circumstances to circumstances is called the variable. For example, age is a variable that varies person to person. Height is a variable that varies person to person. Weight is a variable that varies person to person. Temperature is a variable that varies places to places. Okay. So you understand what is variable. Now, after understanding variable, you need to understand what is data. Data is a rectangular representations of some quantitative and qualitative measures of some attributes or some phenomena that are represented by column and row format, where column represents the variable and row represents the observations. Computer science people, they tell column as a feature. Statistics people, they say column as a variable. Computer science people, they say row as a subject, and statistics people, they say row as a observation. So this is the data. And how many data types? There are many different types of data. So there is a cross-sectional data. So when the data is collected at a certain point from a certain locations, cross sections, that is called the cross-sectional data. There is a time series data, when data is collected by time over a period of time. For example, like if temperature are collected throughout the year for all her 365 days, minimum and maximum temperature and average temperature, then that will be the time series data. Now there this time series data, and there is also called spatial data, SPATIAL, spatial data. That spatial data means data is collected from different location, different geographic locations. When data is collected, that data is known as the spatial data. When the data has a geographic location and time together, that data is known as the spatial temporal data. Spatial temporal data. Okay, now there is a within the data there is a quantitative variable, there is a qualitative variable, that is different. Okay, now the learning objective 2 is telling you generate insights through sorting, filtering, and conditional formatting the data. So once data is generated, if you sort the data by one variable, then you get some insight of the data. What is the minimum age and what is the maximum age? If you sort the data by ascending order, and you take a look at the first observations value of the sorting variable, you will see the minimum value of that sorting variable. And then if you sort by descending order, then you will see the highest value of that variable. So, and then filtering, you want to filter, you want to see the group of people who belongs to the education level corresponding to completing only high school. Then you are filtering the data by only high school level educations. And then there is a conditional formatting that you are conditioning on your data on 2-3 different attributes. For example, you want to collect only female data who completed high school educations and the age between 18 to 25. So that means 3 conditions you are putting. Okay, after doing that, now the learning objective will construct and interpret frequency, relative frequency, and percent frequency and distributions for categorical data. Okay, so now you can do the categorical data. Now construct and interpret frequency, relative frequency, and percent frequency distributions for qualitative data. One is quantitative data, and then another one is categorical or qualitative data. Construct and interpret histogram and frequency polygons to visualize the distribution of quantitative data. Okay, after doing this, now you can do what are the learning objective? Construct and interpret cumulative frequency, cumulative relative frequency, and cumulative percent frequency distributions for quantitative data, and interpret the shape of a distribution of data and identify positive skewness, negative skewness, and symmetric distribution. Calculate and interpret measures of locations such as mean, median, geometric mean, and mode. Calculate and interpret measures of variability such as range, variance, standard deviations, and coefficient of variations. Analyze and interpret distributions of data using percentiles, quartiles, G-score, and empirical rule. And finally, identify outliers in a set of data, construct and interpret a box plot, create and interpret a scatter chart for 2 quantitative variables, and calculate and interpret the covariance and correlation coefficients for 2 quantitative variables. Okay, so these are the learning objectives. Okay, in this case, now let me quickly go and finish up until in here. Okay, then I will go some computations by using software. So Now 2.1 overview of using data, definitions and goal. I have given my own definitions of data and variable that you have noticed in past 15 minutes. Now in the book view of the definitions, now I'm going to discuss data are the facts and figure. Any figure is also data. Okay, data are fixed and figure collected, analyzed, and summarized for presentations and interpretations. Okay, so data is collected, data are facts, and from that data, so we can do construct some frequency table and some graphs. Okay. A variable is a characteristics or a quantity of interest that can take on different values. An observation is a set of values corresponding to a set of variables. Okay. Variation is the difference in a variable measured over observations. The role of descriptive analytics is to collect and analyze data to better understand variations and its impact on business setting. A random variable or uncertain variable is a quantity whose values are not known with certainty. Now remember, what is the difference between variable and random variable? Variable age is a variable. It is just the variable. The characteristics or phenomena that vary person to person, places to places, circumstances to circumstances is called variable. But what is random variable? Random variable you can predict with certainty. Okay, it has a probability with it. A random variable or uncertain variable is a quantity whose values are not known, with certainty. So for example, if you toss a coin, can you say like with 100% certainty that head will appear? No, right? That is what you cannot do. That is, but you can predict with a certain probability level. If you toss a coin, the probability of appearing head is 50%. This is what you can say. So that is why it is called the random. But it is not with 100% certainty. You can say it with certain level of certainty. So if two coin is tossed, what is the probability of appearing two head? So it is 1/4, because if you toss the coin first time, two head can come, two tail can come, first coin head, second coin tail, first coin tail, second coin head. So that means 4 sample point can appear there. So you can say that, well, probability of appearing two head when two coins are tossed is 25%, but you cannot say with 100% certainty. Okay. After doing this, now I want to discuss these two definitions. So what is sample? What is population? So let me explain these things. So totality of all elements under study is called a totality of all elements under study is called a totality of all elements under study is called population. What does that mean? Suppose I want to study I want to study a particular disease of the deer population in Mississippi. Then all the deer in Mississippi is called the populations. I want to study the particular food habit of the bald eagle in Mississippi. Then all bald eagle in Mississippi is called the populations. Okay, I want to study the prevalence an incidence of COVID virus in Mississippi, then all populations who are affected, by the COVID virus will be called the populations. Okay, so totality of all element under study is called the population. And then what is sample? A representative part of the population is called the sample. What is sample? A representative part of the population is called sample. Okay. So now you understand what do you mean by representative part. Suppose I want to study the sleeping behavior of the undergraduate student of University of Southern Mississippi students, undergraduate students of the University of Southern Mississippi. Then if I go like freshman student, sophomore, junior, senior, and collect the data by proportion of original percentage of these four group of students, then it will be a representative part. On the other hand, if I focus more senior students, and then my sample will have more data from senior students compared to the freshman, junior, and sophomore, then the data will not be representative. In that case, my sample will not be representative, and the result that I draw from that sample will not be unbiased. That will be biased. Okay. Now, what is random sampling? Random sampling is a sampling method that allows gathering a representative sample from the population. Okay, so suppose now take a look at that. If I want to study only on the freshman students and their sleeping behavior. Okay, so University of Southern Mississippi, suppose currently has 2,000 freshman students who enrolled this year. So 2,000 freshman student and their name has been written in a piece of paper, and there are 2,000 piece of paper corresponding to 2,000 students, and those 2,000 piece of paper are put in a big bucket and randomly mix them, and I took a sample of size 100 from them. Then I am impartially picking the student. That sample will be called as a random sampling. Random sampling can be done with and without replacement. If you take a sample and do not replace it back to the bucket, then that is known as the sampling without replacement. And then if you put it back to the bucket, then it is known as the sample with replacement. Okay, when the sample size, when the unit of the population is small, in such a case, it is better to take sampling with replacement. On the other hand, if the units in the population are very big, usually we do sampling without replacement. There are two types of random sampling known as sampling with replacement, sampling without replacement. Okay, so now quantitative data. What is quantitative data? That are considered quantitative if numeric or arithmetic operations such as addition, subtraction, multiplication, and division can be performed. If arithmetic operation cannot be performed, they are categorical data. Okay, so for example, height and weight, by these two variables, if you create a new variable known as the BMI by arithmetical operations, then that data is known as the quantitative data. Okay. On the other hand, for the education has a category. 1 means primary education, 0 means no education, 2 means middle school, 3 means high school, 4 means college educations. Then there is a 0 for Caucasian, 1 for African American, 3 for Latinos, 4 for Asian. Then if you add education level with the race level, you are not getting or creating any meaningful variable there. Okay, so that's the reason, like arithmetic operations among the categorical variable is not possible. Even if you do some kind of arithmetic operations, the creation of the new variable will not make sense. Okay, now after doing this, there is a cross-sectional data. Cross-sectional data are collected from several entities at the same time or approximately same point in time. Time series data are collected over several time period. There are other types of data, but longitudinal data, those I'm not going to discuss in here. But let me stop in here and do some basic computations. Okay, do some basic computations. So data necessary to analyze a business problem can often be obtained with a statistical study. Statistical studies can be classified as experimental or observational. In an experimental study, a variable of interest is first identified. What we want to see the outcome from that experimental study. So that means a variable of interest first need to be identified. Then one or more other variables are identified and controlled or manipulated to obtain data about how they influence the variable of interest. So that is experimental study. There is also observational study. A non-experimental or observational study does not attempt to control the variables of interests. So a survey is perhaps the most common types of observational study. Let me explain these two, experimental study and observational study. Suppose in Mississippi 2024, there are altogether 5,000 newborn baby diagnosed with a specific kind of physical condition. Okay, out of suppose 25,000 babies born in 2024 in Mississippi, out of these 25,000, suppose I want to say 1,000 or maybe 500 or 700 baby will have a specific problem during their birth or with their baby, and these problems is almost same for all of these 1,000 babies. So the health official, public health official, they said that, well, let us investigate what happened during their pregnancy period, what are the characteristics of the parents during their pregnancy period. So they do what? They call all of those 1,000 parents, and then they ask, during your pregnancy, did you smoke a lot? Did you drink a lot of alcohol? Did you eat a lot of meat? Did you drink a lot of soda? Did you eat a lot of protein? Lot of questions. Did you work by standing? Did you travel by 1 hour, 2 hour each day? These are the questions they are asking their the child's parents. Okay, and from 1,000 of those child's parents, they conducted a study and they collected the data in order to see whether same types of pattern exist in the data. Those type of study is known as the observational study. They are going back, they are going past in order to find the reason why this 1,000 baby born with a specific type of birth defect. So they are doing this type of study is known as the observational study. Experimental study, I want to give these and there and want to see the output. For example, clinical trial are all known as the experimental study. So like a disease need to be cured, and few pharmaceutical companies come up with a medications, and then they give same type of patients. One is getting the false medicine. That means no medicine is in there, but it is just a sugar coated small tablet. But another group of people, they are getting real medicine, and then they want to see whether they will get rid of the disease. Okay, so that is called the experimental study. Experimental study would always have a experimental study would always have a dependent variable or response variable. Okay, now let me discuss some of these things by using some kind of computations. Okay, so suppose I have this data. So 5, 9, 15, 7, 8, 12, 16, 17, 19, 15, 10, 9, 10, 11, 19, something like this. These are the data. Okay. From this data, I want to compute some statistics things. What are those things? I want to compute the 5-number summary statistics. I want to compute. So 5-number summary statistics, if I want to compute, I have to arrange them in a ascending order. So the most smallest one is 5, and then second one is 9, 7, and then 9 is appearing 2 times. 9, 9. After 9, I get 2, 10. 1, 2, 10, and 10. I got this 10, and then I got a 8 in there. I got a 7, and then I got a 8 in there. I got a 8 in there, and then I got here. After 10, I got here 11. I got here 12. I got here 15, 16, and then I got another 15. So I got another 15 in here. 15. And then I got 17, 19, 19. So these are the things I got in here. So in this case, now let me count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Among these 15, so then there is 7. 1, 2, 3, 4, 5, 6, 7. So this is the middlemost positions. This is known as the median. This is known as the median. Okay. This is known as the minimum. This is known as the maximum. Okay. So median, minimum, maximum, and the half of these, like 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 1, 2, 3. So that means the average of this 9 plus 9 equal to 18 divided by 2 equal to 9. This is my first quartile. That means 25% of data falls below this. And then 1, 2, 3, 4, 5, 6. So there is 1, 2, 3, 4, 5, 6, 1, 2, 3, 1, 2, 3, 4, 5, 6. So that means middle two is this. Now 1, 2, 3, sorry, 1, 2, 3, 1, 2, 3, 15 plus 16. This 15 plus this 16, average of this, which is equal to 15.5, is the third quartile. So this 15 plus this 16 equal to 31 divided by 2 is known as the third quartile. So we have found what? We have found minimum equal to 5. We have found minimum equal to 5, maximum equal to 19, and then we have found median equal to 11, and then first quartile equal to 9, and then third quartile equal to 15.5. This 5 number is known as the 5 number summary statistics. Okay, so we have learned 5 number summary statistics. Now, after doing these things, these numbers, if I add all of this number, 5 plus 9 plus 15 plus 7 plus 8 up to all 19 in here, if I add them and divided it by the total number of observations, that is what known as the mean. That is what known as the mean. That is was what known as the mean. Okay, so mean is written by sum of xi divided by n. This is the way mean is computed. Now, how the median will be computed? Mean is computed. Now we want to do median. I have already computed. This is what the mean. This sum of xi, that means all observations are added and divided it by total number of observation in order to compute the mean. After computing the mean, now we want to show you what is median. Okay, we want to show you what is median. In order to do the median, in order to do the mod, now mod is the that observation which is appearing highest number of times in the data. In this case, we have seen the number that is appearing most of the time is 9 and 10. 10 is appearing 2 times, 9 is appearing 2 times, and also 19 is appearing 2 times. So mod equal to what? Mod is the observation which is appearing most of the time, which 9 is appearing 2 times, 10 is appearing 2 times, and I think 19 is appearing 2 times. So this is the tri-model. If in this case, suppose 9 is appearing 3 times, then this would not be the mod. If 9 appear 3 times, then 9 will be the mod. Mod is the frequency which is appearing highest number of times in the data. Okay. Now, I want to do some basic computations by using Excel and by using R. Okay, let us first do these things by using R. In order to do these things by using R, I want to go there and open in here. And then I want to open this basic R, very basic R I have opened. So when you open these things, R, you just write download R for Windows, and then you can download this R and it will be your start menu. Or you can write download R for Mac computer, so then it will be downloaded. Okay, so after downloading these things in here, suppose I want to enter some data. So I name it here data 1, and just I want to enter some data 10, 15, 15, 17, 9, 10, 9, 10, 9, 11, 13, 16, 17, 18, A 19, 17, 17, 19, and 19 like this. Okay, this is the data. So these data appears there. Now if you write here, I want to write this is my data one. I want to write summary, summary, summary and data one, and you will see the result. So is it minimum, maximum, first quartile, third quartile, mean. Now this is the data I want to find their average. If I write here mean, data one, and you see the mean has been obtained. Okay. So the thing that I have computed, I already compute these things. Now this, it is called the console. Okay, this is called the console. But if you want, you can save it, but saving this one would not be helpful at all. What we will do, we will go to the open and open a new script. And this script is known as the editor. Are you seeing editor? In this case, we will edit, we will make change, we will delete, and finally the important thing we will save. What we will do, we will write code in there, we will keep some code, we will delete some code, we will do all type of additions on this editor, and finally important thing, we are going to save it in there. How can I save it? For example, the data that I have put it in there, I just copy these things, and I want to put it in here. Okay, the data is in there, this data. Now I want to save this one. I want to save this one. File. This is now active. If we want to save this, this window must be active. That means cursor must blink on that window. So this editor window cursor is blinking. Are you seeing? So now it is active. I want to save it. File, save as, and I want to save it in the desktop. I want to write it fast R code. First R code. I want to save it in the desktop. Okay, I want to save it in the desktop. First R code. So now after saving these things, now I want to close it. It has been closed now. Now it has been closed. Now file, open script, and then desktop. If we go, and then first R code that I save, I just open it. So now this has been opened. Okay. Now I want to run this code in here. Cursor is blinking. If I put my this finger on the control and this finger on the enter, this finger is in the control and that finger is in the letter R. Are you seeing it is transferred? It has been transferred. Now I want to find the mean of data one. Okay. Now control R. I am seeing that. Now I want to find the minimum of this data one, and then I write it. Now this, you are finding the minimum. Now I want to go to the maximum data one. Now if you hit enter, you see this. Okay. Now if you want to find the median, then I want to find the data one, then this is the median. Okay, mean, minimum, maximum, median. Now if I want to find the summary, this summary, then I can do it data one like this summary. So we have just learned a very simple thing. Okay, so okay, let me give you another definitions before starting the same thing by using Excel. Okay, so now come in here in this PowerPoint slide. I want to go to the PowerPoint slide and I want to add definitions in here, statistics. The definitions that I want to add in here is known as the word. I want to make it as a 16. Now I want to put a statistics. So what is the definition of statistics? Collection analysis and inter collection, analysis, interpretation and presentations, collection, analysis, interpretation and presentations of data are called statistics. Okay. Are called statistics. So if someone asks you what is statistics, you just put three words: collection, analysis, interpretation, and presentations are called the statistics. Collection of what? Collection of data. And analysis, after collecting the data, you have to analyze the data. You have to impute the data in a calculator or computer. Then you have to do some kind of analysis, find the minimum, maximum, missing values, summary statistics. This is called the analysis. And finally, you present your data in the format of a table or in the format of a graph. So collection, analysis, interpretation, and presentation of data is known as the statistics. Now, the things that I have computed using using R, I want to compute same thing by using now Excel. So if I go there, open the Excel, Excel has been opened. Now, if I want it like this way, paste. So data has been pasted like this way. Now, if I go there, text to column, and then next, comma, and then finish. So data has been put like this. So now this data has been collected in this format. And now I want to present this data in a like this way. Okay. Data has been put like this way. Now, after putting this way, I want to find the mean of this data. So if you find the mean of this data, you just write here, come here. If you want to find the average, and then if you want to find average, and then if you select all the way from here until there and hit enter, this is the average. Now, if you want to find the minimum, and minimum, how can you do that? Minimum, and then if you put here all the way from here to there, then this is the minimum. And then if you want to find the maximum, then you have to put here MA. If you want to find here maximum, then you have to come here MAX maximum, then you can find here maximum. Okay. Now, if you want to find the summary statistics, I think it would be descriptive. Let me see what is that. Summary statistics. If I want to find descriptive, no, they're not descriptive. Uh, Okay, descriptive statistics, it will work in another format. Go to the file option, adds in analysis toolpack. Okay, you have to do enable the analysis, go to the file option, add in file options, add in analysis toolpack, Excel add in. Okay, analysis tool add has been added. Select check analysis toolpack and click OK. Go to the data tab, data analysis. Go to the data tab, and after data tab, click data tab and click data analysis. Data tab, data analysis. Analysis toolpack, data analysis. Now click on the data analysis, descriptive statistics. Okay. And then input range, all of this. And then if you put here, okay. 19 columns, output range, summary statistics. That's it. Here is the summary statistics you have obtained. Okay. So now there is a Cartesian, these things, minimum, maximum, sum. This Cartesian skewness, there is a skewness means whether the data is skewed to the left or skewed to the right, something like that. So if it is negative, so that means skewed to the left. If it is positive, then skewed to the, if this value is positive, then skewed to the right. Kurtosis means like how peak the distribution is. Okay, leptocratic, those are the things. So for time being, forget about these things. So these are the basic discussions about how to conduct computations by using R and Excel, and the basics of summary statistics and some definitions.